Alright, question 4. When doing a chin-up, a physics student lifts her 40-kilogram body a distance of 0.25 meters in 2 seconds. What is the power delivered by the student's biceps? Alright, so let's go have a look at how do we approach this question. It's question 4 over here. They told us the delta x over here was 0.25. They told us that the time here was 0.2 seconds. Alright, they gave us the mass of the student, which was 40 kilograms. How nice of them to tell us how she weighs. And let's see what else. No. So, what is the power delivered by the student's biceps? Well, first of all, we need to calculate what is the... Oh, not 0.2 seconds. I made a mistake. It's 2 seconds. Forgive me. Let's raise the 2. Just the 0. Just erase the 0. Alright, there we go. Nice small eraser. Erase. Alright, just 2 seconds. Okay. So let's go back to the question. Alright. Okay, so we can see here that she's doing a chin-up, so she's exercising, so she has to start from rest, and when she gets to the top of the bar, she also stops before releasing herself to come back down again. So therefore, the kinetic energy at the bottom and the top is 0, so kinetic energy, or the change in EK, will equal 0. Also, we must understand that the force that she's delivering is a non-conservative force. So when calculating the work that she's putting in here, okay, we use the formula W. Oh, I think I'm still on eraser. Let's go back to pen. Alright, the W of the non-conservative force is the change in EK, okay, plus the change in EP. Okay, now we know that's equal to 0, so that just equals then to the change in EP, which is further equals to mg hf minus hi. Okay, so when she's hanging from the bottom, okay, when she's hanging at the bottom of the bar, alright, she hasn't pulled herself up, okay, she's at 0. Okay, so 40 kilograms, alright, multiplied by 9,8, alright, multiplied by 0,25. Okay, 0,25 minus 0. Alright, and that gives us an answer of, therefore, W and C is equal to, that looks like it's going to give me an answer of 98. 98 joules, yes, definitely. That is 98 joules. Perfect. Now we can calculate the power. Therefore, we know that power is equal to the work divided by time. We know the work is 98. And we know that the time taken is 2 seconds. So therefore, final answer, the power of her biceps is 98 divided by 2 is 49. 49 watts of power by her biceps. Okay, quite a straightforward question. Okay, a little bit of working out to do, but quite a straightforward question nonetheless. Okay, that was question 4. Let's have a look at question 5. Question 5, the unit of power that is used on a monthly electricity account is kilowatt hours, symbol kWh. This is a unit of energy delivered by the flow of 1 kilowatt of electricity for 1 hour. They want us to show how many joules of energy you can get when you buy 1 kilowatt hour of electricity. First things first, before we go and answer this question, now that we do. Okay, so they are telling us here that it is 1 kilowatt per hour. Okay, and we know that 1 hour is equal to 60 seconds. Alright, that's 1 hour. 1 hour is equal to 60 seconds. Alright, let me just make my H a little nicer for everybody to see. There we go. Alright. we know that 1 kilowatt hour is equal to 1,000 watts per hour. Alright, 1,000 watts per hour. Alright, so in order to find out, as the question reads, in order to find out how many joules of energy can we get, alright, it's 1,000, alright, multiplied, alright, we know that there is 60 seconds in 1 hour, okay, or 1 hour there's 60 minutes, in 1 hour there's 60 minutes, and then we know there's 60 seconds in an hour, and 60 seconds in a minute, 60 minutes in 1 hour, 60 seconds in a minute, all over 1, which gives us to 1,000 kilowatts per hour multiplied by 3,600 all over 1. And that gives us an answer of 3,600,000 joules of energy when we buy 1 kilowatt hour of electricity. Okay, so quite a simple question here. Okay, we first need to understand that 1 kilowatt is 1,000 watts per hour. Okay, we need to understand that there is 3,600 seconds in 1 hour. Okay, so finding out how much energy is taking the watts multiplied by the number of seconds, and we get the total amount of energy in when we buy 1 kilowatt hour of electricity. Alright, wonderful. Let's have a look at the next question. Okay, this is question number 6. Question number 6 reads that an escalator is used to move 20 passengers every minute from the first floor of a shopping mall to the second. The second floor is located 5 meters above the first floor. The average passenger's mass is 70 kilograms. Determine the power requirement of the escalator in order to move this number of passengers in this amount of time. Okay, so first things first, clear the board. We draw our margin. Alright, and now let's go have a look at the question again. So 20 passengers every minute. The second floor is 5 meters above the first floor. So we know that H in this case is 5 meters. Okay, the average passenger's mass is 70 kilograms. Alright, this 70 kilograms. Oh, I'm sorry about that, my board just jumped. Alright, so we know that the average mass is 70 kilograms. Okay, and if it's 20 passengers, we can times it by 20, okay, to get an average mass of 1,400 kilograms, if all of them weigh 70 kilograms. Alright, then they want us to determine the power requirement of the escalator in order to move this number of passengers in this amount of time. Okay, let's just check what the time says. The escalator is used to move 20 passengers every minute from the first floor of a floor to second. So every minute. Alright, so let's have a look at how we're going to approach this question. So, alright, we need to calculate the power. Alright, so we know here, oh, and T, because I said every minute, so T is going to equal 60 seconds. Alright, so we know the total mass over there was 1,400 kilograms. Okay, so we know that W, okay, this is a change in the gravitational potential energy because it's moving from one floor to the next. So the only work here is that's going to be done here by the escalator is the gravitational potential energy, which is mgh. Okay, and we know that that is 1,400, the total mass, multiplied by 9,8 meters per second squared, multiplied by 5. Alright, if we take 1,400 and we times 9.8 and we multiply that by 5, we get an answer of 68,600, alright, joules. That is the work, therefore. So therefore, power equaling work divided by time is 68,600 divided by 60. Let me get my straight line going. Alright, therefore power equals 1,143.3 watts. Alright, and that is the power requirement of the escalator to move this number of passengers in that amount of time, every time. Okay, wonderful. And that concludes this worksheet or this exercise of questions.